Alright, so this is the periodic trends in reactivity. This is the lab that goes along with Goal 3 periodic table. This is Nick. Say hi, Nick.
Hi.
Hi, Nick. I'm Mrs. Otry, and Nick is going to demonstrate the lab. And the first part he's going to do is show the reactivity of metals in water. We have two metals. One is magnesium. So if you would come get a little close-up of magnesium. Magnesium is a soft metal. It's shiny and it's silver. Okay, soft because I can bend it and break it off just like that. Okay, and calcium is the other metal we're going to test. And they're both in the same group. Calcium's a little bit harder than magnesium. So, okay, so we're going to see what happens when we put them into water. Go ahead, Nick. It's all yours.
That was the magnesium?
That was the magnesium strip, yes. You can tell, you can say that part though, at least. I'm going to put magnesium into water. Yep, like watching paint dry. Mm-hmm.
Pretty boring.
Yeah, go ahead and do that calcium.
Alright. Dump in my hand or dump it in?
You can just put a little bit in there, yeah. Hopefully we are starting to see something. I can see, I don't know if the camera can see it. What do you see coming up, Nick, so far?
A little bit of bubbles.
Some bubbles, definitely a sign of chemical reaction. It's taken a little while, but definitely we are seeing calcium react with water. The water is becoming cloudy. And magnesium's still doing nothing. Ooh, a little fizzing action too. Okay, that's part one. So we're back at part two with Superstar Nick. Alright, now, we're going to test the metals with acid. We have 6 molar hydrochloric acid to use. We've already set up the metals in lovely little containers. We have magnesium, zinc, tin, and calcium. All white or silver metals. Now we're going to see what the reactivity is with acid. So just don't drink it. Go ahead, add some in. Start with the magnesium. That was much more exciting than the water.
Yes, it was.
Okay, you didn't add that part in there.
It smells amazing.
It smells amazing. Okay, great. Bubbles, fume, reacted quite quickly. All right, excellent. Go ahead. Zinc.
Should I keep adding?
Yeah, go ahead. You're not... Okay. Can you get in there and see that there is some reaction in there? It's not as exciting as the magnesium. Can you kind of see it a little bit? There's a little bit of bubbling. Yeah, let me see if I can shake it and get...
It's a little bit of fumes or smoke.
You can see it bubbling on the outside. Yeah, you can see a little bit of smoke with it, but it bubbles on the outside. Not as fast or as exciting as magnesium, but it is reacting. The zinc is reacting. All right, go for that tin.
Again, not much.
Yeah. Right. So how was your weekend? It's exciting as tin gets. All right, and the last one is going to be calcium. Look at now, he's loving to add all that acid in there.
You have to. Some better reactions out of it.
Okay, we are getting fumes coming up out of it. It's reacting, it's bubbling. Well, I can smell that one, definitely. My sinuses are now cleared out. Oh yeah, some foaming. Can you hear that too? Not as probably loud as the magnesium was.
Heat.
Heat, look at that. And even our camera woman has discovered heat. Definitely good signs of a chemical reaction. So reacting with with acid is supposed to be a characteristic of metals. Not all metals are going to react with hydrochloric acid, as we saw. Tin does not. Some of the other ones do, but they all vary in how they react. That's the important part. Okay? Excellent. Thank you, Nick.
Yep.